My name is Sivakumar. I'm a vice president at Cisco. I'm part of the compute business unit, and all your UCS questions. We're here to talk to you more about that. And I also lead our solution related work, and I'm joined by Tushar, who is a distinguished engineer, our leading AI ML solution architect. So in the next, I think 45 minutes or so, what we are really going to cover is how are we accelerating AI for our customers? What are we doing to help our customers embark on the AI journey and get going faster, right? It starts with the typical marketing slide that simply says AI is here and AI is everywhere, and we see AI being actually implemented or penetrating practically every walk of life, every industry we have known so far. And it is a very large economic impact by the 2030 timeframe, looking at a $15 trillion contribution. But if you look at infrastructure spend, it's 300 billion by 26 or 500 billion, and depending on who you ask and who you talk to, it can be double or triple of that by the same time. So it is a big number. Let's keep it that way. And then we also think absolutely a vast amount of enterprises would be embarking on some type of AI journey in the near term. While the promise and the potential of AI is there, it's actually bringing a very different perspective to how you think about infrastructure at the core. You look at compute, GPUs, and of course GPU is the heart of that, but also the power and cooling and many other requirements are significantly different from what we are used to. The network, we heard quite a bit from Paresh and team on how the network architecture is actually quite different and unique when it comes to AI, and how that presents in itself IT with new things to do. And storage is no less. In fact, if all of these are what we are doing is GPU is the engine, it's really the oil is the data, and the data comes from so many sources as well as storage. How do you bring it all together is a very significant undertaking. But with AI, what IT is facing, I mean, there's AI in enterprise, AI in the cloud in so many ways. But if you look at enterprise, which is where we are really discussing this conversation, IT is really saddled with new silos of platforms, new silos of infrastructure. And the more they go from training to fine tuning to actually having a more real-time system that is really deployed in inferencing, it is a really significant challenge for how do I integrate, how do I make this work with my existing systems, how am I going to scale and operate this? And that is really the area this discussion is all about. What are we doing to bring that, to simplify that journey? At a higher level, when you look at accelerating AI and how Cisco goes about it, it's about really delivering an AI-ready data center powered by a complete Cisco portfolio. Transform data centers to deliver AI workloads anywhere. I mean, right now, training and fine-tuning is a big deal. So a lot of these happens well inside your data center or in your cloud. But when you get into inferencing, it's practically a highly distributed world in that sense. We absolutely think looking at AI is looking at a full stack conversation. AI is not about just having a GPU and being done with that. It's about having a full stack conversation. It's about simplifying the operations, because the more you think about it, the more you realize it is actually new. It is very different. The applications are very different. So how do we simplify the infrastructure and operational model of that? Secure by design is really another major tenet of why we are looking at it from Cisco perspective. So all of these translates into what we are going to discuss as what are we looking at? At the highest level, when you look at AI, it's really about looking at a data engineer, looking at data preparation. And the blue colors really indicate the AI journey: training, fine-tuning, inferencing at the edge and the data center. And you have the user with the prompt and response. That's a typical system we see. Underneath, the most popular things we know of: accelerated compute, GPUs, and of course the network fabric. And the model performance, the performance of any system you're looking at, really is tied to the infrastructure and how infrastructure is optimized. But when you look under the hood, AI demands many of this piece parts of the system level things to come together. Infrastructure management and automation is a very big part. How do you manage and operate these things as they come, especially when they are integrated in your mainstream? Virtualization and containers. Many IT are still standardized heavily on virtualization, but many of the AI workloads are containers and Kubernetes engines. AI tools and frameworks. And of course, as you look more and more into this, the security context of AI, observability, all of these, and the persona that really make up what is a fully operated AI system is by no means a trivial undertaking. If you look at Cisco's portfolio across the entire spectrum, the light blue color is all what Cisco brings to bear in this space. We are looking at a foundationally, the network fabric is the Nexus and the Nexus Hyper Fabric. We heard them talk to what they do. Unified computing system, that's what we do. So we build a full portfolio of servers optimized for AI, racks, blades, and the whole variety of them. The management of that comes with Nexus Dashboard or Cisco Innersight or the security cloud. So those are foundational elements for our AI, and many of these we have AI optimized capabilities. And then on the left side, you see a full set of security products in portfolio. And then on the observability side, Splunk and Thousand Eyes and a variety of others. And then we partner with leading vendors in the industry when it comes to hypervisors or container management or Kubernetes with of course, with Nutanix here, VMware and Red Hat mainly, and also, of course, extensive work with NVIDIA to be able to enable what we would call as a more optimal solution around this topic, which really supports your AI journey. So looking at this picture, one has to understand when an enterprise, when a customer really embarks on this whole system has to work in unison to be able to get most out of what you're buying. And fundamentally, this is the biggest effort what Cisco brings to the table and how Cisco is enabling AI for our customers. Building these solutions and turning them into simple to deploy, simple to reproduce is a core part of how we are bringing AI to our customers.
So going back to the slides at the bottom, you have Nexus for training, and then you have for inference you have Nexus Hyper Fabric. So is that the strategy then, to have different infrastructure targeted for the training people and then the inference people, and then maybe something else for generative AI work?
So, very good question. I think if you look at underlying what Nexus and Nexus Hyper Fabric really means in that context, Nexus in the context of this is truly the physical system or the switches we build. Hyper Fabric is an AI optimization layer that runs on top of those switches that connects your AI systems together. So they are equally applicable whether you are running a training type of workload or an inferencing type of workload. Anything that flows through the network, we can look into them a lot better through our technologies and our software capabilities to be able to help you in the AI journey. So that's one way to think about it. So all of these in general apply to AI in the journey, whether you are actually in training or inferencing or fine tuning for that matter.
So wouldn't the Nexus Hyper Fabric be part of the infrastructure management layer, though?
Sure, it can be. We call it more foundational from the sense that Hyper Fabric is very specific to also the AI related pieces as well. But your point is very well taken. It can be in the management and operations layer, but also it is part of the core technology that is very unique in itself. How can we, what can we do today, or how can we help today, right? This, Jake showed this slide as well. We talked quite a bit about the Nexus portfolio. We have a compelling portfolio from the compute standpoint with UCS. We have the UCS from a fabric or from a chassis perspective. We have our X series, And in those X series, we support a full breadth of GPUs as a sidecar to compute. So it's in fact a very unique design in that the GPUs are actually a modular entity that goes next to the compute, that once you connect, the system actually bridges that together, which helps in cycling GPUs independent of the compute. So that's a unique part of the design in itself in X series. That's not new thing that I'm talking about today. It is foundational to how we bring GPUs to the compute. But of course, we have the standard rack mount servers that are like anybody's servers that have a support for a whole breadth of GPUs from NVIDIA to others as well in that.
Steve, I'm not familiar with Cisco Silicon One. Is this a FPGA solution or?
No, Cisco Silicon One is is our next generation silicon that goes into our switches or
So
routers.
it's internal IP process.
It is our big next gen. In fact, practically speaking, many of our future products, switches, routers, and all that will be built on top of Silicon One, and there are many variations of Silicon One at different speeds and feeds available that actually goes in for pretty much. In fact, that's where all the hyperscalers are building in as well. So that's just a foundational silicon chip that is part of our network designs, network products. The next few minutes, what we are going to do actually is spend some time going over many of the AI-ready solutions that we have done and explain just sort of what have we taken up in our side of the house to build and make sure AI-ready infrastructure is in place and what can customers do with that. Solutions really are something that Cisco has been doing for a better part of 10, 15 years. They are Cisco Validated Designs. They provide faster time to value, lower the risk, better predictability, and deeper resilience in terms of what we build. We have partnerships across storage vendors. We have partnership across software vendors, ISVs and OSVs, and of course with the GPU vendors who we build them into our UCS servers as well. What are we talking about? So when Paresh and team they talked about quite a bit of reference architectures or validated designs on their network side. See, that really is foundational, or that really is one of the foundations for these blueprints. They have published CVD for AI-ready or AI networks that really takes many of these capabilities. But then when a customer is trying to deploy these CVDs, we come in, we look at everything we do from the whole stack perspective. We start with our converged infrastructure, FlexPod or FlashStack. These are our partnerships with FlexPod is with NetApp or FlashStack is with the Pure Storage. Or we have a Nutanix GPT in a box solution, which is a hyper-converged offering that again is a package solution that we build. Or we have partnership with other vendors such as Cloudera, who is again a different logic, right? So unstructured data lakes actually bringing in that capability in a software-defined world. So each of these is a very large customer base that is actually looking to bring AI into the fold. This is where the data lives, this is where the systems live, and this is where their real-time systems are running. So now, if you think about our customers wanting to embark on an AI journey, not everyone wants to stand up a brand new silo and say, I have a brand new investment, I can do it. Everyone wants to see, I am a XYZ shop. I'm trying to do AI. What can you do to help me? This is really the number one area where we can deliver optimal solution for AI, but also allow them to keep the investment protection on what they have done so far, their best practices, their IT is ready for this. That's the journey we are on, and we are starting to build many solutions in this. But on top of that, AI is a very different beast. Even though the infrastructure logically is the same, there is a lot of additional optimizations, there is tuning, there is a specific way you have to set up the network as well as the servers to be able to say it's ready for AI. And everyone has plugins and whatnot. So bringing those elements together is the foundational work of our Cisco Validated Designs in this AI space. We work closely with NVIDIA, we work closely with Red Hat, many other vendors for that matter. And when we look at these solutions, we are really looking at the use cases that are really ready for large language models or computer vision models or generative AI models. And then we leverage these sources coming out of Hugging Face or NGCs or many other sources where we are getting these models and then building the solutions on top of them.
So how do you design a solution? So for example, somebody could come to you and say, we have 3 petabytes of storage, it's on VAST. We have GPUs from NVIDIA, there are H200s, we have 1,000 of those. How do you approach that, right? How do you build that solution? Do you look at storage performance and then build your network so that you can always cover whatever is happening on the storage? Or are you looking at the GPU and you look at the GPU requirements, or you kind of mix it all in? I mean, that's an art by itself, right? Assuming the workloads change all the time.
You're getting to the heart of the issue that the everyday IT person is saddled with today. What you just said is very, very foundational to the challenges that our everyday customers calling us with. The data scientist people are fine. They at least seem to know what they're doing. Right? The everyday customer who's now starting on their journey, this is a daunting discussion. What you just asked is by no stretch of imagination something that just comes naturally in this time frame. And we are actually going to walk through specifically how we are going down this path, answering this question in the next few minutes. Just give us a few minutes, we'll try to get to this answer. So how do we go about this? And these are some of the published solutions across the board. They're all published in what we call as a design zone at Cisco, and there is a tagline called AI-ready infrastructure at Cisco.com, and many CVDs go published over there. And we also have many other ways to other things like solution briefs that are some introductory or shorter briefs for them available as well. But let's get into the details of a deliverable. How do we go about this, right? AI transformation. So we have done a lot of the work we are talking about. So how do we think about this problem? First and foremost, when it comes to these solution development, these are not just testing and putting it out there saying we have done some work. It's about looking at how the customers are starting their journey today. They all have, first of all, they have to understand, what do I do in AI when I have to do something in AI? It's not an SAP implementation that you are doing an ERP. What does AI mean to me? I have to start thinking about what part of this business can I bring AI into, which are the best ROI type of discussion in the first place. Then once they know what application or what use case they are going to embark with AI in that sense, then they start looking at a selection of tools or methodology. What model do I have to do? And within that space, there are many models available for them. They need to start to sort through them and get to an answer. Okay, this is the one I'm going to select. And then they have maybe, and this is very heavily now in the generative AI space. I mean, many of these examples we have done, as you see, many are Gen AI. There's one predictive AI discussion, but Gen AI is far more dominant in our customer conversation these days. And many of these customers are not really starting from scratch and building their own foundational models anymore. They are definitely leveraging many of the well-known published model generation and model sizes and parameters and those things. They're just starting from there as a starting point. It's available, but I just don't know where to go. Then they actually start to work with many of the techniques in which they want to bring data to the model, whether it is a RAG-based implementation or whether they have actual data in the data lakes flowing into this. They are looking at many of these techniques in terms of which one do I use to what I do. And there are use cases around LLMs and RAG, but also image analysis and image synthesis. But then when they actually start to really implement and go through a life cycle, that's when ML ops type of use cases comes in. They're really looking at ML ops to see, how do I go through a life cycle of this implementation? How do I update things? How do I update models and so on? So from what we do, we build out end-to-end systems in the lab. We actually build out many of these configurations in the lab, and we work with many of the sources, whether it is the Hugging Face or NVIDIA NIMs or many other capabilities. We go to those sources, we bring those solutions, And we build them, some of them with NetApp or some of them with, we build vector databases or other models. We do a lot of the work, and which we are going to take the time to walk you through a few examples. So you will really know what are we testing, how are we leveraging that work. Then we are building what we think is a reasonable knowledge base on our side to be able to then provide what you just asked. There are no places, there are no just one place where you can go get it. But then we are also translating them to how can I then convert this to something that I can make it easy for my customer. So we go test, we collect all this, we then have this information. From there, I got to extend it to my customer. I got to provide them a journey for, hey, you're going to start here. Here are some guidelines to start. Here are the next steps. And if you are very sophisticated, here is your sophisticated view of the same problem, and then get from there. So we are going to first see a few examples of work we have done. Then we are going to speak to the specific question you asked: how do you help customer through their journey in AI? So there's two parts to this. I'll have Tushar come in first, talk to a few of the solutions we have done in this space. Tushar.
Sure. Hi everyone, I'm Tushar Patel. I am one of the AI/ML engineers who have been working on this solution. So I'll start with FlexPod CVD that is just coming out in next couple of weeks. This is,
Hey, I got it.
yeah, this is a FlexPod CVD with NVIDIA NIM, right? So if you look at the infrastructure, we take UCS X series servers with L40S GPUs connected next to the server, right? And we have taken Red Hat OpenShift bare metal cluster. We created a cluster for the containers. We have used NetApp Astra Trident for providing consistent storage, for storing the models. Then we get into appropriate GPU drivers, because if you look at the industry and all that thing, right, the problem with all these drivers and all that you change one place and it breaks at 3 other places. So we take the supported and fully validated drivers, we install all these AI enterprise stack. Somebody asked a question about NVAIE. So we work almost on daily basis with NVIDIA regarding NVAIE components, choose the right components to be installed there, right? And then NVIDIA NIM, that is today probably the best and most efficient way to deploy in the containers, and the performance-wise most efficient one, because the tuning and the model, the backend connectivity, the microservices that are bundled as a part of NVIDIA NIM basically are optimized for NVIDIA GPUs. So we stand up all these things. And then we have downloaded certain models, we have implemented RAG-based solutions on it. And on these particular CVDs, then we get to the user scales, saying, okay, now how do I test various kinds of inputs, outputs, text-to-text scenarios, and how does it scale? What are the response times? And we are getting slowly into your questions asked, right? So each and every CVD that I'm going to talk about is going to have this kind of a scale. Each and every CVD is going to have several automation scripts, because as we deploy, we develop automation scripts and we stand up the whole stack, right? Making sure that you fully captured end-to-end components. So this one is a bare metal implementation with Red Hat OpenShift, end-to-end configured with NVIDIA NIM, that is going to be published in a couple of weeks. Again, the modality here is text-to-text. Going to the next CVD, now let's change the modality from text-to-text to text-to-image. Now here, if you see with this flash stack, obviously it's pure storage, and we have a separate variation. As you can see, it is sitting on the virtualization layer, right? So everything, all the operational best practices, all the dependencies, all the deployment, all the connectivity, all the tunables change. So we again go through the same scenarios where here we stand up an OpenShift-based cluster. We use Portworx Enterprise to provide persistent storage for your storage needs. And same thing, NVIDIA AI Enterprise Software Stack. But instead of NIM, because there would always be customers saying, okay, I do not want to use NIM. How do I stand up Triton inference server? How do I do some other microservices that I might have the needs for? We capture step by step each and every step that is required to stand up this particular configuration. In this one, we have used, for example, PyTorch framework, right? So there are always going to be variations. And then we have taken stable diffusion, XL and stable diffusion. And as you can see, we are trying and testing them on L40S and A100 GPUs. This would be continuously getting updated as we continue to revise the CVD. The methodology remains same, holistic performance testing, user scales, input-output variations, again, gives us some deterministic behavior. A lot of data is getting captured. And on different types of GPUs, because certain customers would say, okay, my user use case would require probably L40S is more than sufficient. Or do I really need to go to higher end GPU? Right? So we will have all these steps documented in the CVD, automation scripts as a part of the CVDs, as well as we post it on the GitHub. Okay.
So on top of the infrastructure, you deliver then reference systems around software packages and so the typical NVIDIA AI enterprise play.
Correct. These are 100+ page documents, which is like you have a hardware box sitting in front of you. How do you get it to AI ready?
So if I'm a customer, and I'm familiar with Portworx and Red Hat, can I go to Cisco and then say, give me the whole thing? I mean, can I even buy GPUs from Cisco through the USDS program?
Absolutely. UCS is basically an industry standard server.
So in theory, I don't have to talk to anybody else besides
No,
you
in
guys.
practice also, you don't have to talk to anyone else. We can actually deliver you the whole system.
I think they prefer that.
I'm sure they do.
So when I said that word whole offer before,
Yeah.
this is approaching and getting to the point of like this is a fully contained product experience. It sounds like you said this is forthcoming. Some of these.
No, these are done. There are several CVDs published. The one before is just a week or two from, because these CVDs are about 4 months of work in the lab, but there are about 15 that are published already. This is the 16th one is coming, but he just started with that. That's the way to think about it.
And the variations and the steps continue to vary from CVD to CVD. But as far as servers, and like, for example, if you had to have FlexPort stack and you want to confirm it on virtualization layer, pretty much underneath the best practices and Ansible scripts remain very consistent.
Right, but it also means that the customer has to follow the versions for Red Hat and Portworx, right? If there's a new version, you might not necessarily certify that particular version.
So typically, we document almost all the versions that we have tested. And if there are any discrepancies, they are also listed, because as a part of this particular CVD, it is a support model. So it is heavily used by our tech, referenced by tech to get through the customer. So everything is documented saying these are the things. But yes, to answer, there are going to be certain elements where, I mean, we cannot keep up in the CVD each and every version.
But I'll give you one context, so it's actually very important. The infrastructure, reference architecture, best practice, whether how you connect your compute, your network, your storage, physically, and configure many of those things, actually remains consistent throughout the AI journey, if you will. So there are updates in packaging, there are updates in software and other things. Those things do not necessarily have to change in fact, that's how we architect the platform in such a way that you can remain very consistent in how you deploy. And this will have a lot of correlation or similarity to how you deploy your standard data center workload. But with the AI, it will be more optimized for higher throughput, higher connection, higher QoS settings, and other things that are much more AI centric. But once you are done with that, operationally, how you update, how you patch, IT can follow a very similar practice around this, but it is different.
That is the traditional IT version, right? The reality is that in NIM, for example, there's a new release every 6 months, right? And the new release comes with new features and bug fixes. So there could be a point in time where NVIDIA says, well, we found a bug, we make a change to the API, which they do, because they basically say every 6 months there's a new release, but after 9 months we kind of abandon that version for a new one. So AI is a very fast-moving target, right?
You are spot on. So there are two answers I can provide to that, right? So we will more than likely have another CVDs published with that particular version of name, and we will have documented, because as Shiva highlighted, there is continuous CVD work in AI ML team currently happening. So we will capture it like in partnership with NVIDIA as a part of another stack or another solution, or literally you will have to work with NVIDIA just to do this. Because in this partnership, NVIDIA will take a support call and help us out with that particular anomaly.
I think overall it's a great solution in the sense that a lot of organizations who start don't have the knowledge for every single component, right? And putting the pieces together is a major challenge by itself.
Yeah.
And in not connecting, the network cable or the fiber cable, it's more like getting a system that is kind of efficient, right?
Correct. So the trouble and all that we have to go through is, for different pieces, we have to go to different sources. Some of them are correct, some of them are outdated. And so our intent is to document almost end-to-end everything and provide Ansible scripts. So customers do not have to go through those particular things. It would appropriately pull the right dependencies and all that. So moving on from...
Is there a comment on your end?
No, I was just saying, like, the two references so far, the FlexPod, the notion of the Flash stack, those relationships with NetApp, those relationships with Pure Storage. You'll also find I'm not going to speak for them, but you'll probably find a corresponding equivalent capability that they're expressing through some type of a validated design. And each vendor is going to have their own validated design, perspective.
These are both joint validated.
These are the
designs.
joints. So
They will also exactly follow this same design, in terms of.
This is like a gold standard, my guess is there's harmony amongst the players that are being displayed on screen.
A gold standard.
NetApp had their NetApp validated architecture. Yeah, it'd be like a TR dash whatever.
Yep.
Okay.
Absolutely. So going from converged infrastructure to big data, right? So here is a big data solution that is deployed with Cisco Data Intelligence Platform, right? As you know, all corporates have tons and tons of unstructured data, and form of text messages, images, etc. And whether it is a training or inferencing or a fine-tuning job, getting the right data set is one of the most important aspects for your AI journey, right? And then the second biggest challenge is labeling and classification of this data. Because unless your data is accurate, your model accuracy suffer, and a lot of other things break down. So here, in partnership with Cloudera, we have worked and stood up a solution where we have deployed LLM, and the CVD goes into multiple types of LLMs and all that. Then we demonstrate how do you train this LLM with the existing data lake-based data? Then we go and demonstrate that hallucination problems, which LLMs are known for, right? How do you stand up RAG, various types of RAG databases? And then using Cloudera AMs or ML prototypes, we have gone into the steps of various kinds of few shots learning, zero shot classification. We help you classify the data and appropriately chosen so you can create appropriate data sets for your particular AI journey, right? So these are the kind of validated designs. These are 150 plus pages documents again, and we go into not only just AI based practices, even job scheduling on GPU farm or job scheduling on scale cluster. Okay, for this kind of a job, please do schedule it on A100 GPUs or H100 GPUs if you have those, or L40S. All those best practices have been captured in a single place.
Why don't I speed up a little bit? I think we will come back because I need to cover the last section quickly. So the other one, I'm going to give a quick one on these ones, and this is, it's changed here. It hasn't changed over there. How do I
Something's happening.
Okay, it's working through that. It is clearly it is.
It's running on a CPU instead of a GPU.
I think the hyper Wi-Fi is having some issues.
And so is this solution, by the way. It is also running on CPU. That was going to be the highlight of this topic. So this is another. This is a different solution. This is actually a medical diagnostic solution. Truly having, actually, if you think about it, many of these inferencing problems, not all of them require the highest end of the highest GPUs to do things. And if you are only doing a few, and this is an image processing type of a solution where you actually take an X-ray, looking for pneumonia, diagnostics, it runs through and says, this person doesn't have pneumonia, done. This guy has pneumonia, go send it to an expert and get that going. This is an inferencing system built, but given the use case, you can actually run this on a small hospital in a 4-node server cluster. So this is a CPU-based system running a specific LLM in this process and addressing a medical imaging actual solution. But again, we develop the entire best practice for that, and we also demonstrate, okay, if you're doing economical things, smaller systems, here is where CPU stop, here is where GPU starts and goes, and that's a very, very good information for many of our customers. They actually don't know this information. Coming back to your question again, this solution was working closely with Intel to actually deliver a complete solution for an AI inferencing use case. Last but not least, in the examples is a solution. I should have clicked a long time ago because not coming. But last solution we are going to discuss is a Nutanix GPT in a box. We have a very strong partnership with Nutanix. It's a converged infrastructure or hyper-converged offering with them. But what Nutanix has done is also gone one step further to actually build the entire AI stack as an automated capability on top of their Prism software. And so it is actually a single click deployment. And we also have GitOps. So you actually buy this infrastructure. Once you get the infrastructure, you can actually download the GitOps repository, and pretty much in a couple of hours, your whole system is up and running with all these tools and Kubernetes engines and the storage context. Think about it. If we go to IT and say, what are you trying to do? Oh, he's like, I just want to get started on AI. I want a system. I'm doing inferencing. I think my data set will be a couple of petabytes, and I think I'll have 50 users. Something like that. We'll say, recommend this system. We have tested this for this configuration. Get it and download the GitOps. Boom. 8 hours is up and running. This is the difference when we can test, when we can absolutely have an opinionated point of view. That's what makes the whole journey for our customers simpler. If you really look at AI, what we talked about is really one of these pieces. The solution and the validated designs is what we talked about. But just getting AI readiness is a whole suite of things one does. It starts with certification, whichever software you're doing, release by release, OS by OS, hypervisor, the certification work. There are benchmarks published on a regular basis for in the ML-Perf community, training, inferencing, edge, and everything. We're going to come to the tools in terms of the sizer and power calculator. We also have AI bundles. We talked about the solutions, of course. We also have AI simplified bundles. These are ordering bundles called AI pods from us, which are simple and which are easy to say, this is what I want, this is the number of users, boom. We can ship the infrastructure for you. Then, of course, enablement and training, that's a big part of it. We have training program, we train our field, we train partner field, we train customers. So there is a full-on training program. Then, of course, last but not least, GitHub and automation, right? Automation, we work with Ansible. We publish many of our automation scripts on the GitHub for these solutions because the models we test, we may be testing several models, but you may be choosing a different one from Hugging Face. But the infrastructure deployment, as well as the best practice for setting it all up and then bringing new models is not very different. It's very reusable from an automation standpoint. So now let's go to the last topic. This is where your question, this is where we are going. I'm not going to say we are here yet, but this is, we are in the starting point or even in the early stages of this journey. AI advisory. because this is an area where the more you think about it, the more the models and the whole world reaches a little bit more stability, and not like every 2 weeks something new comes that's completely redoes what you relearned, what you have already learned before. The more stable it gets, the more you realize enterprise is starting to slowly get started. Okay, I want to do AI. They initially start with, okay, I have some idea of workload, I got to do some sizing, I got to buy the basic system, I got to make sure I'm right. I don't want to overbuy, I just want to buy enough so I can actually be safe in starting. But then they get very sophisticated. Oh, I want to do training, I want to do fine tuning, I want to do multimodal, I want to this mix and match. It gets quite sophisticated very quickly. So you have customers in the full spectrum, anywhere from getting started, I just know what I need to do because I saw one of my, another company does this, so we need to do this too. Oh, I'm in my second or third generation of AI. I know what to retire and what to get later. That's the whole journey of going through and building tools, particularly sizing tools, then getting into advisory tools that even takes a lot of our own designs and actually put a chatbot in front. I mean, this is what we do everywhere, right? So we have so much of documentation, so much of repository. We can actually put a chatbot in front and say, why don't you talk to that one, and it will tell you what to do over time. I mean, that's our intent, is to get to the point of sophistication where we can actually be a trusted advisor to our customer. To that extent, we'll just take you through a simple example here. Tushar?
Yeah, so as you asked that question, right, sizing request example. And this is a customer, for example, who is starter or intermediate level, as Siva highlighted, wants to get started, but wants to make sure they are choosing right infrastructure, right GPUs and all that. Some of the questions are, hey, which model would work for my use case better? Or say, I have tweeting output and I want to give 128 word input and all that. Or somebody would say, at the end of the day, I have some vector database, or what if I want to use L40S GPU, or I have an existing old GPU, would this run? Right? So those are the initial starter conversation. So that one, we are coming out with a tool very soon. And this tool, I'm sure you Google, NVIDIA has the GPU advisor and all those things, right? It's very GPU-centric sizing exercise. There might be some angle to system there, but not. But here is where Siva said we are heading. What is customer's AI strategy? I want it in a production environment. I want it to be running all the time, HA requirements. I have workload characteristics which would have multiple models, and there are going to be varying ratios, some LLMs, some image processing, some mix of that. As a matter of fact, then they would say, well, I have a larger model which would shard across the GPUs. What are your best practices? Then they would say, well, at the end of the day, I am going to pull data from multiple sources. There is going to be some sensitive data in the corporate database.
What about CXL capabilities on either one of these?
CXL capabilities?
Yes.
At some point when it matures as a product.
Okay. Thank you.
It's on the horizon.
Okay.
So coming back, so again, the intent is how do we advise customer in this journey? So we believe with our CVDs, the amount of testing that we do, we have tons of data captured. We have tons of knowledge captured. So that foundational piece is in there. And we have testing expertise and we have partnership angles. So we believe we can be great advisors to customer in their AI journey. So
yep, and to be very candid, right? This is really the next. I mean, training and building large models is probably going to be a thing of the past. You're going to get into the world where customers are much more in turnkey. I need to get started. I have this problem and I would like quick recommendation. I want to move forward, right? These are the areas where we are thinking ahead in terms of how this is going to evolve. So we are continuing to build products. So there is no, I mean, you don't have to worry. You will get servers, you will get GPUs, you will get every vendor GPUs from us. So you will get all the core products. It is this type of full end-to-end system thinking Why should we do and why can't everybody else do? Because it's our portfolio. We really have the ability to bring it all together, security, packaging it in, observability, all the layers of the pie, we can actually have a play. We work with the software vendors, we work with the models, we work with the others, so we can actually bring in that trusted advisor model. I mean, you aspire for something that you are close to, that is in a reasonable adjacency for you to be there. That's our next, that's really where we are going. I mean, to sum up, I mean, absolutely meet the AI moment with Cisco. We are here, we are absolutely embarking on a pretty extensive and elaborate work stream. And we have world-class AI portfolio with compute, switching, management. We have broad ecosystem partnership. We absolutely think customers can embark their journey with confidence when it comes to AI with Cisco.